So today I'll be going over the triangle congruence theorems, SSS, SAS, ASA, AAS, and HL. Okay, so basically it is if three sides of one triangle are equal to the three sides of another triangle, then the triangles are congruent. For example, let's say this triangle and this triangle all have congruent marks, then they are congruent. When all three sides of two triangles are equal in length, there's only one possible way to construct the triangles, pretty much ensuring that they are definitely congruent because there's no other way to say it. Next is SAS, the side angle side congruence theorem. It basically states that if two sides and the included angle of one triangle are equal to the corresponding two sides and included angle of another triangle, then the triangles are congruent. The explanation is that the included angle is the angle formed between the two given sides. If two triangles have two sides of equal length with an equal included angle, they must be congruent. Is that if side length AB and PQ, BC and QR, and angle measure and angle B is congruent to angle Q, then triangle ABC is congruent to triangle PQR. Next is ASA, angle side angle congruence theorem. If two angles in the included side of one triangle are equal to the corresponding two angles and included side of the another triangle, then the triangles are congruent. The included side is the side that in between the two given angles. If two triangles share two angles and the side between them, their overall shape and size must be the same. Again, I will show another example with triangles A, B, C, and P, Q, R. Okay, so let's say angle A is congruent to angle P, angle B is congruent to angle Q, and length AB is congruent to length PQ. Then the triangle ABC has to be congruent to angle PQR. Okay, next is AAS, angle side congruence theorem. If two angles in a non-included side of one of the triangle are equal to the corresponding two angles in non-included side of another triangle, then the triangles are congruent. Since the sum of the triangle interior is 180 degrees, knowing two angles automatically gives us the third angle. If two angles and only any one corresponding side, not the included one, are equal, then the triangles must be congruent. The example here is if angle A is congruent to angle P, angle B is congruent to angle Q, and length AC is congruent to length PR, then triangle ABC is congruent to triangle PQR. Okay, lastly is the hypotenuse leg theorem. This only applies to right triangles. If the hypotenuse in one leg of a right triangle are equal to the hypotenuse in one leg of another right triangle, then the triangles are congruent. This theorem applies only to right triangles, like I said. The hypotenuse is the longest side, and if one leg is also equal, then the triangles must be congruent. In these two triangles, AB and PQ, are the hypotenuse. If triangle ABC and triangle PQR are right triangles with AB is congruent to PQ, like I said, the hypotenuse is, and any leg, one leg, side AC is congruent to PR, then triangle ABC is congruent to triangle PQR. In conclusion, these 5 theorems provide different ways to prove that triangles are exactly the same in size and shape. And if any of these conditions are met, then we can conclude that the two triangles are congruent. Thank you for watching. Please request for any more theorems explanation.